and welcome to Desk of Lady Ada.
Hey everybody, it's a cold and windy night outside, and so we're indoors here at my desk. It's full of stuff because I'm doing all sorts of things, including keeping hydrated, but did some filming yesterday, so it's exciting. We'll have a great new video for people. And then today we're here doing some engineering at my desk, and what we're going to be working on is we got these microbits that we've been playing with. These are little $20-ish MicroPython / PXT, BBC devices, and they have a Bluetooth chip on them and some LED matrix on the back here. And the idea that we had today was, well, we've got this microbit, but what if we want to add accessories to it? So let's look at it on the overhead.
Here's just a nice photo.
Oh, that's a nice photo that we took.
Yeah. That's what it is. Is there one right?
That is nice.
Isn't that nice?
Nice. Okay. And this is the board, is what it looks like. So it's very small. And you've got a couple of pads here, pin 0, 1, 2, 3 volt and ground. And when you power it from USB, you can, right now it actually says line 1.7. Oh, there's an error going on because it's not running the code it's supposed to. But you can use alligator clips. So we have an alligator clip to demo. If you want to connect to ground, you can. This is a tough alligator clip. Or as they say, crocodile clip. Let me try the other side. These really old clips.
Crocodile.
Yeah. So you can, crocky clips or alligator clips. So you can clip on, but if you want to do more than just connect to these 3 pins, which are basically analog digital pins, you can connect using this socket, basically. This is an edge socket, so for people who remember cartridges for like Nintendo or Super Nintendo, these were the same edge connectors. And here's the deal with edge connectors. Basically, they cost just about nothing to, actually PCI cards, ISA cards, computer cards also have edge connect sockets. They're very, very cheap, and you can have tons of pins. So to add them, it's basically you incurring cost onto the main board or the adapter board, not onto the device itself, because it costs nothing to add this connector. It's just traces. And so if you're looking for a very, very low cost, not something that won't stick out or shred or bend, having an edge connector is really good. On Circuit Playground, we did something kind of similar, just because we've been doing it with the Flora for a while. We have this kind of quote-unquote edge connector, which you have to use alligator clips with. This is like the most challenging clip. Okay, so this is another way to do it, but it's not meant to slot into something. Instead, you have to use alligator clips. There's pros and cons. This a pro is you get a lot more connections that you can use alligator clips with because you've got all the way around here, whereas down here you only get 5 because you have to have them be a certain distance apart, and they don't go all the way around. But this has the benefit that it can go into a socket. So a while ago we made a little adapter for us, this socket, and this breakout, it's actually a socket on a breakout. Let me see if I can move it. Yeah, what's up?
Okay, well, I'm going to try to ask questions. That's our little symbol there.
Yeah.
Do they use hard gold on the microbit, or is it just EING?
It's probably just ENIG. I mean, it's not hardened gold. This is, it's a $20 device. They probably use whatever the default plating they got from the fab house. I think they went gold, though, to reduce oxidation, because kids are going to be handling it, and it's going to get damp and sweaty kids' hands covered with peanut butter. But this is a socket, so this is the other side, that edge connect socket. This is, I think, a 0.05 inch pitch connector, so 80 pins total, 40 on the front and then 40 on the back. But if you look carefully, the 40 on the back aren't connected, and that actually is a smart decision, right? You don't want it to be, if you put it upside down, it could possibly damage or have a different connection. You want it to be only usable one way. So even though this connector has 80 pins, I only soldered in the 40 down here because those were the only 40 used. And then again, not all 40 are used because some of these big pads are essentially the same as 3. You can tell it's like 3 or 4 contacts get used, and then there's 4 or 5 in between. So the nice thing about an edge connector is you slot it in. I mean, it's really durable.
No cables.
It's nearly indestructible.
Not the USB thing where you flip it on one side and then flip it on there and flip it the other.
Well, you could put it upside down, which is why I like the right angle connector, because it'll intuitively you'll want it to be face up.
I'm talking about the thing that happens with every USB cable. You're like, whoops, whoops, whoops. Oh, third time's a charm.
Yeah. So, I broke out all these pins, and this was for basically our development as we're hacking on microbit stuff and MicroPython, having something I could connect things to. So let me see if this still has that old demo on it. That'd be cool.
Question,
Oh, yeah.
Why even have contacts on the back if they do not connect?
I don't know exactly. That's a good question. I think for the through-hole pads, it does add mechanical stability. So for the pads, for these big hole pads, these big round ones, having a through-hole connection, you do need to have some, PCB houses won't make drills that don't have, they're called annular rings. You have to have a ring of copper around it. These pads back here, yeah, they're not, there's no real reason to have them, except maybe they look good. I don't know why they put them there. That's a good question. Yeah, I don't know. Not necessary, but maybe to make it clear that it's an edge connector. Anyways, this is running MicroPython, so let me reset this. And the Python code I wrote is very minimal. And it doesn't, hold on, let me grab a cable. Jumper. Try again. One moment. Sorry to reset it. Okay, so the demo I have on here, it's a very, very simple demo. It's just an accelerometer demo. Because I actually couldn't easily get text on here, so I just made it so when you move the board around, the acceleration is read off, and it just draws a line. I think it's this direction. Yeah, that direction. It just draws a line telling you, hey, you've moved it around. Because I could do basic pixel stuff, not necessarily like full text and drawing, because the microbit is only 16K of RAM and 128K of flash, which is a fascinatingly small processor to get MicroPython running on, but it does work. And so after we got this working, it is possible to get the OLED to do something, and then with some hacking, we actually figured out, there's a way to get the RAM frame buffer, the font buffer data. It is possible to extract it, and we'll probably figure out a way to have that display on here as well, so you could display little messages and stuff, so that could be really fun. And again, you're not going to get a huge amount of technical innovation going on here with 16K of RAM under MicroPython, but maybe using the microbit under PXT or Embed Direct, you would be able to get that capability. Because again, for MicroPython, 16K of RAM isn't a lot, but if you're writing it in straight up C, or you're writing it under PXT, which is basically C or JavaScript, that is then compiled down to bytecode, it's plenty. So, okay, so we got this OLED working, and then we actually got a couple other fun accessories working, and we thought, wouldn't it be nice if you didn't have to do any wiring at all to use this with a microbit? What if we could just use, our Feather line, right? This is basically the same OLED, but it's got an auto reset circuit, and it's got a button here, and it's got 3 extra buttons, and it's actually about the same width as the microbit. So having something that this works with, sort of socketed in, might be nice. So I thought I would design that tonight. So that's the introduction to what
Okay.
Does that sound good?
Yeah, that sounds great. We're going to go to the computer in just a moment.
Okay.
Someone was saying, they'd like to see Game of Life on microbit, which I don't know if you could do.
on the little display,
Yeah.
I don't know.
But,
Yeah, that's a challenge.
however, good news. There is some potentials.
I
And-
think it's possible for me to do Game of Life on the OLED because I did have to make the buffer large enough, so I would be able to read and write pixels.
Yeah.
So I think we might be able to get. I mean, it is 60K of RAM is tough.
So
but it
here's
might be possible.
here's a Game of Life running on our Feather, running MicroPython.
So that's a 32 kilobyte of RAM
Yeah.
processor. Wow, 32K of RAM, so much RAM.
Here you go, show under the overhead. Hit reset if it generates a new universe and it gets stuck on it.
Yeah, that's kind of fun.
And I believe this is the smallest like possible thing. It's Feather, so there's a battery. The way I just did that is it showed up as a USB drive on my computer. I dragged over main.py and then the NeoPixel frozen library, and it just works. And I can edit the code just like with text editor or any type of Python editor. It just works. Kind of fun.
Okay.
So
Yeah.
we want to take that power of the Feather wings and bring that to
Yeah, because this.
to microbit.
I think like NeoPixel that you could absolutely do NeoPixel Game of Life because NeoPixels are a lot easier to drive than OLED, and somebody's written a NeoPixel driver. So wouldn't it be cool if you could just pop that OLED onto an adapter, and then we have 50 Feather wings that are all either. Some of them require SPI, but a huge number of them are I2C only, or NeoPixel or BitBang or something very easy to use. So adapting to microbit, you have a shot.
Yeah. Okay, so that's my demo
Okay, everyone's got a demo.
from the Go Get This Thing From Your Deskville series. All right, computer time.
Okay.
Design this thing.
Yeah, I thought I would design this thing, or I get started because I'm going to send out prototypes on Wednesday because if I send out prototypes on Wednesday, I'll get them on Monday. This is like.
Yeah.
This is my guilty pleasure, if I send PCBs out by Wednesday, 4 p.m. to Gold Phoenix, which is what I use for my prototypes, not for production, but for prototypes, I really like them. I get them Monday morning. And so, that's kind of fun to get, really nice, solder mask, silk screen, fully routed, plated slots in 5 business days. I do have to pay $400 for it, but that's why I send out 14 prototypes at a time. So do the math, ends up being about $5 a piece. Okay, so in microbit, we've got the breakout. I've got the reference here in case I need it. The reference schematics is kind of handy. This isn't the true schematic, but it's close enough that we can use it.
Okay, one question. What do you use for version control?
I'm using Git, so you can actually see here. I'm all in one repository, and all of our boards are in one repository.
Yeah.
So Feather adapter. And I'll snag the breakout. I like make files and privacy policies. All my PCBs are from a previous PCB. Feather bit. Let's go with that. And yeah, this is actually kind of the dream of having Feather, right? I was tired of designing the same breakouts over and over again, shield format or a breakout format of trinket or whatever. Now I get the entire Feather library, right? This huge collection of boards, all the adapters, displays, and NeoPixels, and real-time clock, and SD cards, and GPS units, and TFTs, and terminal block breakouts, and Ethernet, and Charlie Plex displays, all of these things, and all the other things that I'm working on. We have the relays and latching relays, servo control, motor control, all the stuff. Having this be available for microbit, it basically means I don't have to go through and design each one over again. What's up?
Someone in chat says they like to use PCBWay.com. They get 10 prototypes in 6 days, total $31, $10 for the boards, and $21 for DHL shipping.
Yeah, I mean, whatever.
Yeah, a lot of people use Oshpark.
Oshpark is good when you have a lot of boards for me, it flips over to be, I like to use Gold Phoenix because they'll do full routing for me and get them to me, and I can choose a color.
Yeah.
And I can have, I can change things, like do 4-layer boards, or if I have certain requirements. But I'm a weirdo, Don't,
Yeah, there is
don't
no
do
best.
it.
It's like whatever works for you. Like
Yeah,
everyone got their thing.
People ask me what I do. It doesn't mean
Yeah.
what you do is not good. It just means this is what I do.
Yeah.
And actually, I have to update because I know I tweaked the library. I added.
What was the name of the place if you wanted to get custom colors, like you were saying?
Oh, custom. If you want Pantone matched colors, we've tried Sunshine Circuits.
Okay.
They're the only ones that would do, for the number that we needed and the kind of things that we needed, that would do weird colors. So we like them, I think.
Yeah. Okay.
Okay, so this is the front of the microbit, and what I did, because I updated it, what I had done is I updated it to match the NRF51. So that's the chipset that they're using. It's basically a Bluetooth chipset, but I don't think they're actually using Bluetooth. It's a little unclear whether they're actually using Bluetooth. I think they're just using the radio, but not Bluetooth for it. And I added all the pin numbering, so like, this pin P021 is also known as MOSI, so then I kind of added P021 here. It's a little confusing how they name stuff. And then I'm going to just delete this because whatever. Well, not everything, just this stuff. And then I thought I would add I'd have a feather layout. So I probably have something I can reuse. I can actually use a feather wing, right? Because it's not a feather wing, but it's similar. So I'm going to pick one with no dimension outline, because the dimension outline is going to be defined by the whole device. And then, yeah, I can have it kind of basically be like that. Let me get rid of the dimension layer, because I actually don't need the dimension layer right now. And what's nice is that this object I made for feather wings also has all the holes. So if you want to do like mounting holes, so that's really nice. So let's start with the pins that we like absolutely, because this is the tough part, right? How do you lay out the pins? And when you're making an adapter to something you already got 50 boards of course I'm going to go through and test each of them, but there's a couple of things you can do to make it easy. First off, of course, make the ground pins correct. So let's connect up the ground pins. This is ground. That's easy to understand. And then down here we have ground as well. Okay, so that's easy. We're done. Okay, so next step, we have 3 volt, right? We have 3 volt power coming out of here. And I like microbill. I like K-Town's 3.3 volt little arrow. I'm going to use that. What?
Beep.
Beep? Somebody's going beep?
No, I did.
Why are you going beep?
Because I just wanted to.
Okay. Beeping is when you get to routing,
Yeah.
not so much at the layout. Okay, so now I got power and ground, so we're actually, okay, kind of rocking out here. All right, so then let's do, we're gonna need a little bit of space here, because this kid's gonna get fun, fast. You probably won't finish the whole thing, but we'll get a decent way through. Okay, next up, SDA and SCL. Okay, so these are the easy ones. We want to do SDA, SCL, MOSI, MISO, S-Clock, URX, URTX. So these are very straightforward pins. We should do those next, because these are like, they're what they are. Okay, so down here we see that these pins are defined as clocking data. If that's what they've decided, I'm going to stick with that, because there's onboard I2C devices and I want to have them match. Now we got beeps. Beep. Okay, and then we want to get S-Clock, MOSI, MISO. So the SPI bus. That's over here. Very easy. I already labeled it. And then you can verify P0, pin 0, 21, 22, 23. If you go here, you'll see P0, 21, 22, 23. So this is how you know that these are the pins you want to use. So we'll label these. And then over here, connect them. Okay, so I2C and SPI are easy. So the thing that's tougher is UART, because I don't think that the UART pads are brought out. So let's take a look. There's target, RX, and TX. Let's see where these go. We made just one gigantic schematic, so we have to kind of follow these pins over here. They go to the NRF programming header. And we're following these pins down, 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 down. And they go to the Freescale programming chip, but they don't seem to go out to the header. So that's kind of sad. So we may have to leave those pins unconnected because it's not exposed, but those pins are what I consider, set pins for all the feathers. The GPS always uses those, so I'll label them, I'll name them for now, and then later on, if we find out that there's some way for us to get to something, otherwise it'll be an error here, and so we'll just remember that when we do our ERC. Okay, next up, reset pin. I don't think that the reset pin is brought out either, which would be like so sad. Let's check that out. Let's see, SDA, SCL, definitely. Column, button, no, I don't think reset's brought out either. Wow, this is like really tragic. Yeah, this is the reset. Looks like target reset is not brought out. Okay, so we can't bring up the reset pin either. And then let's look for AREF. I kind of doubt AREF is brought out. I don't think there is an AREF actually. No, doesn't look like there's any analog reference here. Yeah, man, they don't bring out any of the programming or reset, or they don't bring out USB power either, which actually makes me wonder, do you think I should have a battery charger so you can make it portable with a LiPoly charger? I think that would be pretty useful.
Well, yes, because if you're going to be doing sensor projects, and the whole goal with Feather and Feather Wings is to make it portable, be able to go anywhere and do anything, probably a good idea to give that to the microbit. Yeah.
Okay. Let's do that then. So let's add USB, because they don't bring out USB power, so we'll have to add a USB plug here, and then a battery slot maybe out here, the battery holder, and then charging, and then we'll have to just sort of be like, hey, we're going to do the best we can with the power, and hopefully people don't do anything. Like, we'll probably, oh, actually, will they, is it back, it's probably back power protected. Let's see what the power supply does. So we've got the 3-volt power here. Oh, but this isn't the true schematic. So that's a little bit of a challenge. So it looks like, yeah, they should, well, we can just build it, risk it, and then later on just see what happens. Which is kind of scary, but basically try to power back the 3.3 volts from a low dropout regulator and just have that be switchable on and off. So let's grab from, the similest thing is the TC. So let's go check out the TC. This Feather adapter has its own onboard. Grab the battery charge. Let's grab all this. This is probably like a total crime to do, but whatever. Engineering.
Speaking of the NRF 52 Feather, will
Yeah.
NFC be broken out?
With what?
The the NRF 52 feather, if there was such a thing one day.
If there was such a thing and you saw it while I was scrolling through my boards.
Would the NFC be broken out?
Maybe.
Yeah.
Don't ask, 'cause I don't know yet. Still under design. Want to do it right.
All right.
Yeah. By the way, the NFC isn't what people think it is. It's like it's not as cool as it sounds. You're like, oh man, it's like it can do NFC. It's like no, it can only act as an NFC tag and only for pairing, really.
Do you manually route everything in EagleCAD? Would you ever use the auto router?
No, I didn't even pay for the auto router. Okay, so here's
There you
my here's my battery plug. Maybe I'll flip this around so the battery comes at the bottom. What do you think? Like that? I think that makes more sense. And I got a lot of space here, so like I'm not too worried about where things are gonna go. Okay, so the battery is sticking out the bottom here. That's good. And then I want to power it from USB. So let me grab from like my Feather 32 4. I'll grab the oh, I need the yeah, I need this whole thing. Hold on. I need this. I need all this stuff. Okay, I need the regulator, charger, and then I need USB. So let's close this. I'll grab the USB socket. Hopefully it won't be confusing because it's not for, it's not going to be for data, it's just for, because I don't have access to those data pins. So this will be for power only. So this V-bus will power the battery, which will also get charged from this thing. So this is just one big chunk that will feed into the same 3.3 volt. Yeah, and this is like totally, it's really bad taste because we're going to be backfeeding into the 3.3 volt. But what I'll do is I'll put a switch on here so you can enable and disable the regulator. So it's like, hey, don't, because it's like the power supply and the microbit is kind of a weird thing anyways. I don't completely understand some things that they decided to do. So I figure, you know, I know that there must be a regulator on here, right? There has to be, because if it's powerable by USB, there must be a 3.3 volt regulator, and I think that these two things down here are diodes, so I don't know, I'll survive. So let's look for slide switch. You want a right angle slide switch on off? Maybe.
Okay, you're at the 30-minute mark. How much longer do you want to show this?
Oh, how about another 8 minutes and we'll finish this
All
at
right.
7:30? Okay, I'm getting there. So this will be the on-off switch. This will be USB. And then we'll route this over in here. Okay, we're getting there, We took a break to add USB and battery charging. I think that's worth it, because I think having a portable, like lipoly chargeable thing would be kind of cool. And then this is going to be connected to the enable of the regulator. And we'll connect this up to we'll make a prototype, connect it up to a microbit, and just see if it catches on fire. If it catches on fire, and we won't do it. That's how you engineer things.
Samsung edition.
Exactly. Okay, so we decided that there's no ARAF, this is no connect. Reset, there's no connect. And there is a connection. So this is N. And then we do have a Oh, you know what's funny? Actually, we do need to have a battery and bus power to connect NeoPixels, which is interesting. That
Yeah,
NeoPixel-
David in the chat said Phil's gonna want some NeoPixels in that. That's correct.
Yeah, so our NeoPixel feathering requires VBAT and VBus. But I have to figure out, should we allow it to run off of two AAA? But I don't think you can NeoPixels will run off of two AAA batteries. I think they'll just be unhappy. Okay, so now we have all the GPIOs, and this is kind of fun too, because we want to basically have all the pins connect through here. We have a bunch of analog pins and digital pins. So I thought what we would do is we would just sort of start with maybe set up all the analog pins over here, because this is the analog section.
Someone suggested simply reroute that reset pin to GPIO.
No, that's not a good idea. That's a very bad idea, actually. And here's actually something interesting. So a lot of these pins are shared with the LED column, so that's going to be interesting. But yeah, maybe we'll just get as many of them as possible. Analog ins. So how many analog ins are there? Let's see. Looks like, oh, there is an AREF. Oh, but AREF is connected to SCL, so never mind. So pad 2, 3, 4. So these are the analog pins. 1, 2, 3, 4, 5, 6. There's actually exactly as many as we expect. So, and I think if you're using this, like with all the feather, I think they'll eventually let you turn off the matrix, the LED matrix. You'll have access to more pins. So this is analog in 2, analog in 3, analog in 4, 5, 6, 7, and then we'll set these up. Maybe we'll take a break and go have tasty food. This is analog 3, analog 7, and then I'm just reading off the analog pin number up with this description. So analog pin 2 does not six, 4. So I only have 2 is not connected, but I have analog 0 here. Sorry, 1 second. Analog 2 is P0. Oh, I missed it. It's right here. Okay, so we're already starting to fill this in. Okay, so is ERC happy? This is fine. This is fine. This is fine. This is fine. 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 Okay, so it's got that still got that, and then no reset. So then expose reset. Okay, so now we have these pins up here, and we'll just quickly assign those, and then we just have to route them. So looks like we have just enough pins remaining too, because analog pins have to be down here because that's kind of the analog pin section, but the rest of these can kind of go anywhere. And then of course as I'm routing, or as the way I did it with the ESP32 is it kind of routed them the way I wanted, and then later I went back and realized this pin is an input only pin, change that. So this is P017, P012, P011. P0.10, P0.26, P0.20, and P0.16. So what I'm going to do is have all of the, I'm going to try to use only, for these last pins I'm going to set up here, I'm going to, because most of the feathers, they tend to use these pins for input and output for controlling feathers. I want to have those be the pins that aren't used for anything. So like P0.16, because it's not used for anything else. P0.20 is not used for anything. P0.18. And then I'm going to use the button pins. So P0, so button A is P0.17. Because those pins are used for the buttons, but they're not for the multiplex, display thing. And the analog pins, I think when you do an analog read, it will release the multiplex display, do the analog read, and then re-enable it. So like there's a better shot of me being able to use those pins. So what's left? 8, 9, 10, and then 10, 11, 12, 26. 10, 11. This is LED column, LED column, LED column, button B. So let's do button B, which is P0.26. And then I'll just pick 2 pins. I'll do P0.10 and P0.11. Okay. So a couple pins didn't connect it. So this pin, P0.12, which, let's just make sure it doesn't have any special capabilities. P0.12, nah, it's just like a standard GPIO pin. So that one doesn't get connected, and then RX and TX doesn't get connected, which I think is okay. A little bit tragic, but life goes on. If I wanted to, I could expose that here, because I have one GPIO remaining. And then RX and TX basically don't exist. And there you go. So all of my pins are now set up. So now all I have to do is route it. So that'll be, maybe I'll do another video where I route it, maybe tomorrow.
Yeah, folks are saying they'd like to see some live routing. And we've done that before, but why not? Come back tomorrow or Tuesday night, maybe. We'll see how things are going.
Yeah, I'd love to do some live routing. And then remember, like, for future people watching this, I'm totally guessing on what these pins are good for. I have not really played around with it, but I found that rather than trying to get everything perfect, I like to do my best guess at a good layout. And then I'll actually try every single feather, right? We'll do videos as I try every single feather with the microbit, and then I will determine because sometimes this pin has to be able to do a pull-up, and for whatever reason there's no pull-up capability on that pin. Okay, we'll change it around, or this pin doesn't actually, I got RX and TX swapped because it was labeled differently, or most UVs are swapped or something. Yeah. But we'll actually go through and test all of the capability, and we'll plug in the OLED feathering, make sure that still works, check all the buttons, and then try it out in MicroPython and or maybe PXT, and then maybe we'll even get our feather libraries into PXT, and then you'll be able to use the advanced features. But I think the 7-segment display and stuff, I think for sure I'll be able to get working because it's very simple. Yep. And the OLED maybe. But stuff I'll just be super clear, the Ethernet library is probably not going to work. maybe in PXT, C++, but not in MicroPython.
Yeah. So that gives you a glimpse on how we do rapid development in Adafruit. A lot of people ask us, how is it possible that you can get so much stuff done, so much stuff out? And a lot of it's because we're willing to try stuff, and then we have a good test suite.
You just gotta try. I mean, it's all about just doing it, trying it, and trying it again, because that has worked out so well for us. Not getting hung up on the right way to do it, or what's the proper.
Well, we get pitched by startups all the time. They're like, we want to show you the secret thing, and it's going to be perfect. And if you try to launch something perfect, you're going to die alone. because
Because
it's
you'll
not,
never get finished.
well, it's also, there's a lot of things outside your control.
Yeah.
And what you have to be able to do is adapt and do the best you can and then iterate. And it's just something that comes up over and over, especially young companies are convinced that they can be perfect at launch, and it just doesn't happen.
Yeah. Okay, so you can tell basically what I'll do next time is I'll shove all these parts to the right, and I'll route that section, the power supply section, have this on-off switch, so basically people can enable or disable the battery as power supply, and then we will route basically the rest of the pins. I mean, it looks like there's a huge rat's nest here, but it's really not so bad. It's not nearly as bad because it's like this can be full of vias, and I can route around here and there. And I just have to get these pins through here first, and maybe I'll route them around here. So I'll do these far pins, and then I'll do these closer pins because they're easier. I think they'll be okay. I just have to kind of get them around this corner.
All right, support open source hardware, software, shows like this. I put a code out just for tonight. It's microbit sun. Use it, 10% off later for store until I remember to turn it off.
Okay.
And thank you so much, all the folks in chat.
Yeah. This is how I do hardware, and if I finish this by Wednesday, I'll get prototypes, and then we can put it together. But yeah, a lot of fun prototypes got sent out last week. So last Wednesday, so on Monday, I'm gonna have some fun stuff. Thanksgiving is definitely gonna be a party. Can I say the magic words? MicroPython Gemma.
Yeah, we're gonna do that.
Tasty.
Okay.
Tasty, like stuffing. Okay.
All right, everyone. And that's Desk of Lady Ada for tonight. Later.
Yay. Zoom in.